Right, exponentials. Exponentials are in the form of y equals a times b to the power of x. So x has to be in the power, and it's called exponentials because in maths, that is known as the exponent. So exponentials because the unknown x is in the exponent. Now, for all of these questions, this number here has to be positive. Yeah, there is no such thing as exponents where we call that the base number as well, b for base number. The base number always has to be positive, otherwise it's not an exponential. And then this is like, if b is negative, the whole thing becomes a mess, and then it's like degree level maths, and it's just not something that we deal with. If you go on search, for your interest, if you want to search -1 to the power of x, go for it, but it's a bit crazy. But if you're a maths geek, you can go and Google that, see what it shows you. But for even A levels, yeah, you're always going to deal with a base number being positive. Now, exponentials look like this. They grow exponentially. And keep in mind, I've said that this number A is positive. So that could be whatever you want. But the base number below the x always has to be positive. Now, guys, in this example, what does the y-intercept have to be? So if the equation is y equals a times b to the power of x, what does the y-intercept have to be? Now look what happens. When you make x equals 0 here, you get y equals a times b to the power of 0. So it's a times 1. So in this case, y equals a times 1, which is a. Yeah, good guys. So actually, in this example, for y equals a times b to the power of x, it crosses the y-axis at a. Now, if a is negative, the next one, can you see here I've said b is positive because I always said that number always has to be positive, but a, the coefficient, can be negative. If it's negative, all it means is that it crosses the y-axis in the negative place. Because remember, the y-intercept is a. So if a is negative, it just crosses on the negative side. But it just means it's upside down. So it looked like this. But remember, it still goes towards the x-axis. Yeah, so it still has that asymptote on the x-axis. Oh, actually, I didn't answer that. Can b be 0? The answer is no. Now, the reason we can't do negative bases is because x is continuous, meaning it's not just x is 1, 2, 3, 4, etc. X could be a half. Then the question is, what is -1 to the power of a half? Yeah, I can show you my calculator. Okay, great, it doesn't work, yeah? Hey guys, I hope you're enjoying the video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button and comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. Now I'm going to show you guys what the idea behind the equation of a circle, because it's important for you to understand. Now, the equation of a circle comes from triangles. Yeah, everything comes from triangles. And at GCSE, the center of the circle will always be at the origin at 0, 0. Now, what's special about a circle is that it has equal radius, right? So every point on the circumference has the same distance to the center of the circle. Now look, if I draw a line here, that is the radius. Now this is just some random coordinate x, y. Now from 0, 0, how do you get to this coordinate x, y? Is you go to the right by x and you go up by y, right? That's how you go to that coordinate on the circle. Then you think, okay, what connects all of these lengths together? It's Pythagoras' theorem. So it's x squared plus y squared equals r squared. And this is the equation of a circle with center 0, 0. So guys, what must the equation of this circle be? So it's always x squared plus y squared is the radius squared. Now here the radius is 10. Yeah, the radius is 10. Then we have to square it. So the full equation is x squared plus y squared is 100. Now, you need to know what the sine, cos, and tan graph look like. Now, you have to remember that the sine graph starts at 0. Now, from 0, you might have learned this in physics and stuff, that they're known as sine waves, cosine waves. So it starts from 0 and it does a wave like this, looks like, and it keeps going. Yeah, it keeps going. So I'll do a dotted line to indicate that it does just keep going forever. The sine graph goes up to 1 and down to -1. But sine graphs have angles on the x-axis. At 1 is at 90 degrees. It crosses the x-axis again at 180 degrees. The lowest point is at 270 degrees. And then it crosses again the x-axis at 360 degrees. But you see, I said go from -360 to 360. Right now, I've gone from 0 degrees to 360 degrees. I'm going to do the other side as well. So always remember, something happens every 90 degrees. That's all. And the same is going to happen with the cosine graph. The only difference with the cosine graph is it starts at 1. The sine graph starts at 0. The cos graph starts at 1. Yeah. And then again, something happens every 90 degrees. So we have 1 and -1, we can see. The cos graph starts at 1, and then it just forms that sine wave. It just drops first. So it drops down to -1, and then it comes back up like that. And that takes it to 360 degrees. Remember I said something special happens every 90 degrees. So this is 0 degrees. It crosses the x-axis at 90 degrees. It crosses that at 180 degrees. I'm just going up in 90s. 270 degrees. Then it comes back to its original starting point at 360 degrees. And remember, the cosine graph would just keep going. It will just keep doing that, etc. Then, on the negative side, it just follows the same thing. It just keeps going. You have to remember the shape. So always remember, the cos graph always starts here. Maybe make a note, the sine graph starts here. That's your starting point. And then you draw the graphs from there. And then you just remember something happens every 90 degrees. Now the tan graph is a very interesting graph. I'm going to show you exactly how it works and where it comes from. But for now, you're just going to trust me. The way to remember what the tan graph looks like is just remember it looks very similar to the x cubed graph. So what does the x cubed graph looks like? From 0, 0, it looks something like this. Yeah, that's what the x cubed graph looks like. Now, when I say copy and paste, you just put it next to each other. It just keeps doing that. It has that same shape over and over again. Yeah. Now, between every single tan graph, which we're going to copy and paste, there is an asymptote. Yeah. There is an asymptote between every single tan graph. Yeah. What x value do you guys think this asymptote is at? Something happens every 90 degrees. So this would be -90. Yeah, you have 0. Then all we're going to do is we're going to copy and paste another graph. All right, what do you guys think this point is? So 180. But the next asymptote, yes, will be at the 270s, yeah? I'm just going to copy and paste it over on the other side as well. Let's just draw another one over here. Then we can do the asymptotes, which, as you guys are assuming, is going to be at 270 and -270. Now, we're only going up to 360, yeah? Which means you do not need to do a full curve. We only need to go up to here, to where it crosses at 360. Now, because the way it's shaped, over here on this side, it's not going to be coming from down. It's going to be the upside version. And that would be minus 360. And there's your tan graph. It's really easy to remember, guys. People struggle to remember the tan graph, but it is really easy. Just remember, it looks like x cubed. Okay, copy and paste it on every side. And then just remember, something happens every 90 degrees.